Hello, and welcome to yet another episode of Undercooled, a materials education podcast. Once again, we have a special guest today. It will not just be me and Steve yammering on. We have someone worth listening to this time. So, our guest for today is the one and only Chip Keough, who wears many hats, but today is coming to us from the position of the ASM Foundation. So, Chip, welcome. Thank you so much for coming today. Can we just start with introductions? Tell us about yourself a little bit, how you got an MSE, and what sort of career you've had with materials.
Well, Tim and Steve, thanks for having me. I've become a devotee of the Undercooled podcast, and so I'm delighted to be here. And I have a bit of a funny story. I wanted to be an engineer from the time I was little. And in fact, in high school, I actually went to vocational school because it was the only place I could get 3 hours a day of engineering drafting. And people said, well, you're going to go to college, aren't you? You know, I said, yeah, but I can't get 3 hours of engineering drafting back at my high school. So I had that hybrid education. And I was going to be a mechanical engineer. My dad was an engineer. He was in the industrial furnace business, and I went off to the University of Michigan and started my coursework. And in the meantime, I fell in love and got married and started a family. So right out of the gate, I was a non-conventional student. Then I did a really stupid thing. I was working nights as a draftsman, millwright, welder, and a friend of mine over Labor Day weekend talked me into jumping out of an airplane. I jumped out of the airplane, proceeded to break my leg on my very first fall, and hobbled into the office on the Tuesday after the holiday weekend, and my father fired me. And he wasn't kidding. He was a tough love guy. He said, that was the stupidest thing. You've got a little baby, you've got all these responsibilities. So I had to go look for a job, and I quickly got a job on crutches at Sears, but that wasn't enough to pay the bills, so I hobbled in to East Engineering Building in those days, and somebody said, hey, there's this professor named Flynn up on the fourth floor who is hiring. And I hobbled up to the fourth floor and did a short interview with Dick Flynn, and he says, well, I'll tell you what, if you're willing to go and see the advisor and adjust your courses to go for both a degree in mechanical engineering and what was at the time metallurgical and materials engineering, I think I have a job for you. I said, when do I start? And I started the following week as the foundry tech. And the first time I saw molten metal poured, I was hooked. And that was all there was to it. And so I would say at that juncture, I became this much mechanical engineer and this much materials engineer in metallurgy. And so... but the two together have been my secret weapon. I can deal with the product guys, I can deal with the process guys, and it's been wonderful. But yeah, I had to go through that experience. I would have never been in material science and engineering had I not jumped out of an airplane and broke my leg. So that was a strange path. We all understand that path. If I was the son of an engineer involved in the heat treating industry, and I was not aware of that as a separate study, then we know it's hard to reach these kids who have no idea about materials or anything else. So that's my story, and I'm sticking to it. I graduated in '77 with degrees in both mechanical and materials and metallurgical engineering. And I was not asked, I was told to join ASM and the other technical societies in 1976, and I did, and I've been a member ever since.
That's really funny. We interviewed Peg Jones last week, and she said the same thing.
Yes,
that,
I saw it.
Dick Flynn said, no, that Bill Hosford put his glasses up over his eyes and says, "You will join ASM."
Yeah, it wasn't a question of it was not an option. You joined. I will say this, another funny story, that we have these MMS luncheons, the Michigan Materials Society luncheons, every week at Michigan Today. As another way to make money, my wife prepared those meals. I was a commuter student from driving 40 minutes into school every day, and I would have the vat of chili or whatever it was on the floor in my car driving into Ann Arbor. That was one other way we did to make a little money on the side. So we provided those meals. So I have a long string of attachment to several things in the University of Michigan from back in those days.
I never knew you were the professional chef for MMS. Just one more resume item in the deep lore that we're getting into.
Give my wife credit for that. All I did was transport it. I just delivered it. She prepared it. But
we'll downgrade you to courier then. Well, so after you left the university, I know you went into industry. What did that path look like, and how did you go through your years in industry once you were building off of that degree that you got at U of M?
At the 1977 Foundry Educational Foundation conference in Chicago, I met my first employer, General Motors. I graduated, and in January of '78, I went to work at the Pontiac Foundry, making gray iron blocks and cylinder heads for automobiles. And that's when I realized that the path for me was process engineering. I'm a process engineer now who just happened to be a CEO along the way, and that's what I do. So I worked for General Motors for a couple years, and in a 100-year-old gray iron foundry, the phone rang, and it was at that time the Turbine Components division of TRW, and they were looking for a principal process engineer at their plant in Minerva, Ohio, which is now PCC Airfoil in Minerva. And in the most lucky stroke I could ever imagine, I went from making gray iron blocks and heads to being right in the middle of commercializing the single crystal casting process for superalloy turbine blades. And so then I had to learn a whole new field. I had to learn the ceramics and the polymers and everything that we used. So every ounce of what came out of that Van Vleck book was used as I expanded the processes that I had to develop expertise in. And worked there for 4 years, left a lot of really good friends there. And then I went into business with my brother, and we saw this opportunity for commercializing the Aus-tempered ductile iron process, a specialized heat treatment that turns spheroidal graphite iron into a material that has a higher strength to weight ratio than aluminum. And so we started the company Applied Process, and for several decades I ran and grew that, and sold out completely, sold a fraction of the business in 2014 and sold the balance in 2019. Now today, it's estimated that there's 1 million tons a year of Aus-tempered ductile iron produced worldwide. And so I had the honor and the privilege to be involved in commercializing some new technology, and it was process technology, right? So that's what I do, and now because there are limitations to what you can make out of aus-tempered ductile iron, basically because the process limitations. Now we've started up a sand additive manufacturing machine company where we're printing molds that will lend themselves to being able to make 3 millimeter sections of aus-tempered ductile iron, amongst other things. But that's what I'm working on now.
Yeah, I remember when we started talking about the additive business for making molds for casting, I was super interested in this, didn't know anything about it, and got me so excited about it, I've ended up turning it into a project for my freshman class. But that's a story for another time. The story for today will be, as I said earlier, about ASM, the ASM Foundation, what it's doing for our field, what it's doing for our community. So you mentioned earlier that ASM for you was not an invitation, it was a statement. You will do this. And, that's honestly something that I think we need to do with our students more, is to just really tell them, like, you need to do X. I'm not asking, I'm telling. Sometimes some days they just really need that direction. But once you got into ASM, how did you engage with the organization, and what did your trajectory look like in ASM over time? How did that change?
Yeah, all the technical organizations have, of course, gone through a change over those decades. But a core thing of ASM has always been the meetings and the process-related literature associated with ASM. If I was to try and quantify, the first thing I wanted to do when I got out of school was get a set of ASM handbooks, because it was the source for process information on materials. The other technical organizations, TMS, MRS, and everything else, are deal a lot in their publications with kind of MRL 1 to 5 stuff, right? ASM deals with stuff 3 to 10, right? So if you want to look at some basic research and just trying to develop the basic I was at the America Makes conference here in Golden, Colorado this week, and they're still trying to quantify different alloys in additive manufacturing and stuff like that. There's the processes are young and not well evolved. That's where ASM played a role. And then through the meetings and through the local chapter, I developed relationships with the pillars in the industry, right? And if I had a question about process, I could pick up the phone and I could call that expert, and over lunch, I could learn everything I needed to know to ask the right questions. And so ASM has continued to serve that role. The handbooks per se are not the centerpiece anymore. But if you want to get a book that dives deep on any particular material process combination, ASM has a book for that. And we still have the chapter meetings where people present really salient material on stuff that's being worked on and actually being made. Now we do more meetings. For example, in the Detroit chapter, we do more meetings with AFS and ASM, American Foundry Society, and ASM International jointly, and that's very successful. So the organization's involved, but if I described ASM, I would say it is the process-oriented organization for materials information. And by the way, TMS and ASM are very complementary to one another. TMS papers, more academic papers are published in TMS. More papers that are related to process and things actually being made are published in ASM journals. And ASM has the International Materials Review, the Journal of Failure Analysis, the Journal of Materials Engineering, the Journal of Phase Equilibria, the Journal of Thermal Spray Technology, metallography, microstructure and analysis, and the Shape, Memory, and Superplasticity Journal. So, those journals are people actually making stuff and publishing in those journals. And so I don't know if I quantified it properly, but that's the flavor of ASM.
Oh, I think that's a great umbrella description of what the organization does. And since we have an audience, there's more than 2 people who listen to the podcast now, which is exciting. And we know that there are students out there who do check in occasionally, and there's also, professionals. There's certainly faculty who listen as well. What a student might get out of an ASM membership is very different than what, a mid-career associate professor might get out of an ASM membership. So for the students out there, why should they care? Essentially, what benefit will students get, as an early career, just starting their first job maybe? Why is it a good idea for them to join ASM?
Well, if you kind of divide it into research, product, and process, okay, by the time a student is a senior, maybe even a junior, they might have an idea whether they want to be in the design community designing product, whether they want to be in research, or whether they want to go solve problems. Okay? I would say that, for example, mechanical engineers who want to design automotive components, they're going to be in SAE, and they're going to be in the ASME, okay? They're not going to join ASM. But materials people who feel inclined towards the process things, want to go solve problems, and work on an array of materials and everything else. ASM is a good channel for that. People who want to work on product, there are other, design related things that are more specific, become the world's expert on this product. That's another angle. But for that group, for the maker group, by and large, the ASM caters to
and
those
if I'm
people.
not wrong, I think that ASM, TMS, and ACERS have the Materials Advantage program.
Right.
And so they don't need to really choose. They can just become part of that Materials Advantage.
Right. But the tough thing for all of those organizations is the bridge when they graduate, right? Because at that point they're making a choice. They're no longer going to be a material advantage with all these things in here. They either have to join one or numerous societies there, and it's hard. It's hard to bridge that. All the societies have a problem with that, I'm trying to tell the story that worked for me, right? And I know those relationships are still being developed all the time. I see it at those dinner meetings. I take youngsters over and introduce them to people who are experts in a field that they're interested in, and they start a lifetime relationship. and that is the way it works. It's a network. It's a community that if you don't know the answer to something, or you don't even know what question to ask about a material process combination, there is somebody in that organization who can guide you in the right direction, and probably a textbook on that subject. ASM has a big library.
That's great.
Yeah, that point about just making those connections, introducing students to people, that's so important, so valuable, and certainly I've started to realize more in the last few years that most of the value I bring to students is not the stuff that I know, it's just creating opportunities for them, right? A chance to meet someone, a way to make a connection. That's really the value that we're bringing.
Actually, I tell students over and over, you've probably heard me say this, two things I tell them. When you go out in the workaday world, just say yes. When there's a problem and it hasn't been solved, nobody else has solved it, put up your hand, even if you don't know anything about it. Put up your hand, say, I'll take a shot at that. When you're done doing that, you may solve that problem, and then you'll have the tools and the experience that nobody can ever take away from you, okay? But the other part of that is when you graduate from the University of Michigan with your engineering degree, you will have a wonderful foundation, but you won't know a lot of specific stuff. But you will be able to ask the right questions that will lead you to a solution, because you will understand the broad theory. And then when you go out and if you're in the maker world, like the path that I chose, you can quickly become a superstar, because if you go to somebody and you ask them, tell me what you know about this, we're going to solve this problem together. Your theoretical background with their practical experience on this thing, and you can just set the world on fire. And that path worked for me, and I've seen it work for kids that I have mentored along the way.
So maybe this is a good time to go to the next question, which is, so you've been involved in ASM pretty much your whole professional life. So what's the ASM Foundation? When did that come about, and how did you get involved with that?
Wow, I can't tell you the date that the organization. Probably should have researched that, but the ASM Materials Education Foundation is a separate sister organization to ASM. It was established when we realized that we had to focus on getting young people interested in the materials field. For instance, in junior high school, I had shop class. Okay, and we dealt with different materials and we made things and everything else. That kind of went away, and then we became computer modeling people and robotics people. Okay, so the materials part of that was kind of lost, anyway, the organization was formed, and it was formed initially around having student camps where we had students in there, and we had these great hands-on experiments. And if you ever are able to go to see the final presentation at an Eisenman camp at ASM, which still goes on, it's pretty awesome. I mean, these kids get pretty deep in stuff, and some of the research that they do on that week that they're there at the camp is amazing. But what we found out was we were spending a lot of resources to get to a small amount of kids. And we discovered around 1999 that if we could have a teacher's camp and we could take high school science and technology teachers and give them these fun, easy to do examples that are STEM related, and we use clever materials experiments to demonstrate those STEM principles. And it's been a mega hit. We're now, I think we're going to do 45 camps, teachers camps this year. I think Peg gave the numbers in a previous podcast, but we have them. We have a couple distance ones, and by the way, these are centered on hands-on. So even the distance ones, we send the kit of all the materials to the people who are going to be distance learning. And in their kitchen or on their picnic table in their backyard, they're doing the stuff hands-on, distant. And that came about during COVID, right? We had no choice, so we turned on a dime and got that. So there's this key thing that they can do with simple materials, and then the whole curriculum is there for them to have. And they get that curriculum and take it back, and the kids get lit up by it, to the point where we have teachers, now dozens of teachers over those years, who've gone back and managed to get material science classes or even a material science department in their high school. And that is an amazing thing. And we tracked teachers from every district with every demographic, and it's just a wonderful thing. And we have a big lever, because that one teacher who's enthusiastic about it, we figure over his or her career will light up 1,000 kids, with that material. And so we're forging ahead with that with great success.
Like I told you earlier,
and
I just saw that today. A parent and their high school junior came in to talk to us about material science, because she wants to do material science and wants to apply to University of Michigan. And I asked, how did you get involved? And of course, it didn't hurt that her father was one of our alums. But what she said was, what really made the difference was she had a material science course in high school. I said, really? I said, how did that come about? And she said, the teacher said they went to something in the summer. I said, one of the teacher camps? She goes, that's it. They went to one of the teacher camps and they talked to the principal and said, I want to teach this. And they let them do it. And that was amazing. And that's why I want to be a material scientist. So, wow. Just saw it today. It happens. It works.
Yeah, and there are those examples out there. As I shared with you, one of the people who attended one of the materials camps has matriculated through to being a professor, and is now going on to the ASM board. Wow. It's just fantastic, and we're behind it. We have a strong financial basis for the foundation. Carrie Wilson, the executive director, is just knocking it out of the park, and we're growing the program every year, and we have objectives to be to 60 camps and cover every state in the United States, but we also handle Canada. We've had a camp in France, and so the point is, if we can reach down into high school, and now we're teaming up with the Foundry Education Foundation and doing Foundry in a Box. We have year 2 camps, teachers who commit to having material science classes or a department within their high school. They come back for a year 2 camp, and we give them a little higher level experimental stuff. And so we're going to reach further down the line, and we're going to continue to leverage teachers and their enthusiasm for the materials as a tool to reach more students. Because as we know, we're competing with computer science and engineering. We're competing with all these things. Kids don't know about the materials field. And once they realize that there's a whole field out there and everything is made of stuff, and that there are engineers who have to deal with the stuff, have to create the stuff, have to process the stuff. Once they realize that there's a field that specifically handles that, then they get excited.
It sounds like the future is bright for the Teachers Camp program, certainly continuing to expand, more regions, more people, more impact. If anyone out there wants to get involved with this, if someone wants to connect with outreach opportunities through the ASM Foundation, or if they want to participate in the Teachers Camps in some way, how does somebody get connected with that? How could someone get started to help make this happen?
asmfoundation.org. We have a fantastic website, and the staff there will, whether you're a student, whether you're a teacher, whether you're a parent, whether you're whatever you are, a guidance counselor. By the way, we're going after guidance counselors because they have no idea that there's a materials field. And think of how many high school kids take a direction based on a guidance counselor's input. Okay, so we're working in all these channels to try and increase our visibility. But the very first place is to go to asmfoundation.org, and there's the statistics there, there's the contacts there, and they can set you up. Especially teachers, we're always looking for teachers. We like to have 25 teachers in a camp, but sometimes we have to run at lower efficiency with 18 or so, teachers in a camp. So a teacher can just dial us up, and we pay for everything, and they get advanced. What are the credits called? Continuing education credits. For that. So it's pretty wonderful. For instance, we got an Apple camp this year. Apple is helping sponsor a camp, and they still have openings in their camp. Who's not going to take an all expenses paid trip to a camp in California that working with Apple people? So it's really great. And we're very proud of it, and I really want to emphasize, not only are we growing in it, we're maintaining the financial stability of the foundation so that we can pay for the growth, and we're doing a great job, and we're very proud of the team there.
So you've actually talked to me about some really innovative ideas you have for leveraging your network of teachers to help materials programs get more students. Is that something you'd like to talk about?
Yeah, ultimately what we're trying to do, right, is get more kids in the materials field. So the camp is great, and getting them excited is great, but the proof is in the pudding, right? How do we get them connected with the schools? And so what we're trying to do is the schools. A lot of these camps are run at universities and colleges. It's a high density opportunity for that school to engage with those teachers and and explain what they've got going on, and then at the same time, we're still running a bunch of student camps. Okay, so those teachers recommending kids go to student camps that are run places. So we're trying to make that connection between the student camps, the teacher camps, and the organization and the sponsors of the various camps. And it's an ongoing challenge, and different schools are doing it different ways. Some of the camps, some of the industrial members of ASM actually provide internships for kids that have gone to the student camps. They say, if you've been to an ASM student camp, we'll give you a job in the summer as an intern working in a materials company. And that's having traction. But I would say to all the faculty and staff at the sponsoring organizations, it's a target-rich environment when those teachers are there in that camp, and to set up that networking with those teachers and a pathway is something that we want to do more.
Something just occurred to me listening to you, Chip.
Pardon me.
This summer, Tim and I are on the organizing committee for the North American Materials Education Symposium that's going to be in Ann Arbor. And as you know, that came from Mike Ashby, Mike knows a lot about process engineering and certainly material selection.
And we have Mark on our board.
That's right,
now.
Mark Fry. 2 years ago at Carnegie Mellon, Carrie actually came and gave a talk about all the teachers' camps. But I wonder, would ASM Foundation maybe partner with us? We're a pretty inexpensive conference to go to. Could we have a poster session where we bring some of the high school teachers to come to the conference and present how they've implemented their what they've learned at teacher camps? I think the broader materials education community would really get a lot out of that and would go a long way to, we even have a whole session of how to recruit more material students beyond the teacher's camp. And one thing that's beyond the teacher's camp is continuing to involve those who went to the teacher's camps to keep them in our community. Is there a way to help fund some of these alums to come visit us? And I should mention the cost is very inexpensive. It's only $250 for the registration, which, as you know, is really cheap.
Yeah, I would say the answer is, without hesitation, is whatever. I mean, that $250, that's nothing. If we can get our alums, our teacher camp alums, in front of educators, and they can demonstrate what they learned and the enthusiasm of their activities, it will catch fire. It will catch fire. So the other thing, by the way, don't discount our master teachers. We have scores of master teachers who teach these classes, and these are teachers that most of them came out of the ranks of coming through as a teacher's camp, and they liked it so much they said, how do I become a master teacher to teach other teachers this? So that fits right in, I think, with the theme of your conference. And so master teachers would have one perspective. Teachers who have been to the camp would have another perspective, and maybe students who've been taught by these teachers. These teachers would volunteer students to come and
That would
maybe
be amazing.
present.
We have a special
or-
rate for students, only $150.
Well, and the foundation would have no problem sponsoring that. Now, I'm speaking out of turn as immediate past chair. These things have to be. But from what I know about our finances and what we're wanting to spend our money on, that's exactly the stuff. Because ultimately, the outcome is we want kids.
So this
in
is
the material
happening
field.
quickly. Can I just call Carrie up and talk to her? Because we'd want to use your email lists to advertise this meeting, and then maybe letting ASM Foundation make an offer to those that are being sent about how they would cover whatever costs they would cover.
Yeah, Carrie is very busy right now, but I think that she's also interim ASM executive director. So she's a busy lady, but please do. And the staff members, they're busy getting camps all set up right now.
But it would be amazing to hear
very busy
how the products of your teachers camp, how they're actually using that in high school lessons, how they're actually having these conversations with their principals to get a materials course or a materials department. I think having the educators.
And in Southeast Michigan, by the way, we have several teachers now that have material science courses and or departments in their high schools, and they would be a local
So it would be
commuter.
very inexpensive for them to come, and it would be great if we just wanted to target that group to get started to see how it goes. But I'm the chair of the organizing committee, so I have a lot of leeway in what we do, and I think Tim agrees with me, and so I have a strong ally there, so I'm pretty sure we can.
I think it'd be a great networking community opportunity.
It's important that our materials community find ways to grow our ranks. That's been a problem for decades, and we need to do a better job. The teacher camps have been amazing, but we need to figure out how to leverage this and get some multipliers going.
That's what we're trying to do.
There's another really important aspect to this idea of bringing our ASM Teachers Camp teachers to the Education Symposium, which is that I'm not quite sure the right way to say this, but some faculty are maybe a little out of touch with students. And from the recruiting point of view, a lot of us, especially who have been career academics in higher education, just don't know what's interesting or meaningful to a high school student anymore. Like, I have no idea what a 16-year-old is interested in, but I know who does know, and that's the 16-year-old's teacher. So if we can get these ASM teachers to the symposium to talk with faculty about how to actually engage high school students effectively, that would be a phenomenal opportunity for us to improve our recruiting.
I can picture a couple faces of personalities amongst that community right now who would just light it up. So please call Carrie and do that.
And hopefully you can come back to Ann Arbor and visit us. It's August, I think, 7th and 8th. Is that right, Tim? It's a Wednesday and Thursday. And
I think that's
we'll
right.
be putting the link in the show notes to our webpage. But, we're soliciting oral contributions as well as poster contributions. But I could see us organizing a whole poster session for, teachers and students who had been involved or inspired somehow by the teachers' camps. What a great theme to add to our conference. And also, I got to thank you, Chip, because your original story
that'd be wonderful.
You talked about at the beginning of the talk, how inspired you were by pouring metal. Ever since, I think it was Tim who first set this up with us, of casting a little block M by putting melting aluminum in our box furnaces, but then suiting up all the students in the protective gear and having them pour metal. I started doing that with all the students in this archaeology class I teach. making things 3 million years of materials and culture, which grew out of University of Florida's impacted materials on society program. Every student gets to actually pour liquid metal and to look at their faces when they do that. These are kids who were turned off from science a long time ago. And they even complained to me that I use jargon like, you keep using these initials like we're supposed to know what CL means and FE and W. What do those initials mean? But then those same kids, when they actually pour metal, it just ignites something in them, and I see it. And now I'm starting to do that with even my intro courses, even when I have large numbers, because we can push through, 3 students every 15 minutes. And it's amazing. And so I got to thank you for that, Chip, because
it's my pleasure. It was the thing that, there are those of us who, melting rocks will never, ever lose its fascination. So, it's a hook. I mean, everything from art to R&D, right? Everything that's made of metal starts as a casting. I say this over and over and over again. And it's so fundamental to the materials field that, you can't ignore it. And there's something primeval about, melting metal and pouring it into a space, and you break away the space, and you have the thing that was the negative impression. And and they never forget. And kids who even make that little block M, whether it turns out good or not, it ends up on their shelf for their whole life, because they made that, and they remember the day they made that, and they remember everything about that. And that's been that's what I've learned over the years. It's
my father-in-law was a mechanical engineering major many years ago, and his father was a mechanical engineering and chemical engineering major. His father worked at Erie Foundry, and we have his casting that he made, in Dick Flynn's shop up on the 4th floor. It's a brass or a bronze casting of the seal of the University of Michigan. And that's on our wall now because my wife got it when my father-in-law died. So it's something special.
And by the way, that pattern had an error date on it. It had 1837. It had 1837. If you look, is it 1837 on the one you have?
I'll send you a picture of it.
Still into the 70s, they were saying 1837, and then they went back and went all the way back to Detroit.
They changed the date.
And put in 18. So I have one. I'm still moving in here in Colorado Springs, so I don't know where my bronze is, but I've got one with 1837.
So you're right. It lasts for more than a lifetime.
Yeah. So, those of us who are excited about the materials field, we need to use every tool at our disposal to introduce kids to it, because everything's made of stuff. And that stuff is all engineered. It's all processed. It all has to be controlled and safe and all those things. And so it's the most cross-cutting engineering field there is, because every engineering field makes stuff, and materials are in every field, and that's what people have to understand.
This would be the perfect time to pivot to talking about the Foundry Educational Foundation, as we've been talking about casting and about pouring metal and the excitement with that. But instead, I'm going to rain on the parade and say we're already over time, because it's been such a great rich conversation, and we're having these ideas in real time of, oh, we could do this, we could do this. So, being the one in charge of the clock today, I do have one final question, which is always the final question. Chip, you've got an audience at your fingertips here. Anything you want to put out there, anything you want to advertise, promote, preach, this is your chance to just tell the audience anything you want them to hear.
And it's so cross-cutting that for me, it has been a lifelong love and profitable both emotionally, intellectually, and financially. And I encourage kids to look into it because, we have a nice tight community at the University of Michigan. Everybody knows everybody else in the department, and you don't get lost away, and you're not just plopped in front of a computer doing coding and pull down menus. We're actually making things, and and again, I will go back. Just say yes. Try it. No matter what, and if you failed, nobody else has solved the problem ahead of you, So that's what I tell my students. So
that's great.
Wonderful. Thank you so much for coming today, Chip. It's been a great conversation.
It's always my pleasure.
All right, with that, I think we'll end. So thank you all for listening, and we'll see you later.